Hello everyone. Today we are going to see about the instruction format of 8085 microprocessor. So before writing an instruction, we need to find out the format. So first, what is an instruction? An instruction is a command to the microprocessor to perform a given task on a specified data. So this instruction has two parts. One is the task to be performed, that is the operation or opcode, and the second is the data to be operated on, called the operand. So we have two parts. One is opcode and another one is operand. So this operand, again, it can be specified in various ways. It may be an 8-bit data or a 16-bit data or an internal register or a memory location or an 8-bit or 16-bit address. So in some instructions, this operand is implicit. Now we'll be seeing what is the instruction word size. So here 8085 microprocessor has three types of instructions. One is 1-byte instruction, another is 2-byte instruction, and the third one is 3-byte instruction. Now what is 1-byte instruction? So this 1-byte instruction includes the opcode and the operand in the same byte. So the operands are either the internal registers and they are coded into the instruction. For example, consider this instruction move A comma B. Listen here, move A comma B is the instruction and here A and B are the operand. So what is the meaning for the move A comma B is the content of B is moved to A. So here this is a single byte or 1-byte instruction because for move A comma B here in 8085 we are having an opcode sheet. So in that opcode sheet, if you see move A comma B's opcode is 78. So this instruction consists of only the opcode. So and this opcode is stored in a memory location. Normally in one memory location we can store 1 byte or 8-bit. So one memory location occupies 1 byte or 8-bit. So that's why it is called 1-byte instruction. So the move A comma B has only the opcode. So that's why it is called 1-byte instruction. For example, consider the next instruction INRC. So what is the meaning for INRC is increment the C register by 1. So whatever the content of C register, if the increment C instruction is given, the content of C is incremented by 1. So the opcode for this INRC is 0C. Okay, so that is stored in 8100. So INRC is a 1-byte instruction because this instruction consists of only opcode. And come to the next instruction, add B. So add B, what is the meaning for add B is the content of A is added to the content of B and the register is already and the result is stored in A register. So for this add B, the opcode is 80. So for this instruction, it occupies only one memory location. So far we have seen three instructions, that is move A comma B, in INRC and add B. For all these three instructions, we have only opcode and it occupies only one memory location. That's why it is called 1-byte instruction. So in 1-byte instruction, we'll be having only the opcode. That is the operation to be performed. The next one is 2-byte instruction. So what is 2-byte instruction is opcode plus the operand, that is the data bits or the data byte. In 2-byte instruction, the first byte specifies the operand or the opcode. Okay, the first byte specifies the opcode and the second byte specifies the operand. Operand means data. For example, consider this instruction move immediate C comma 00. So meaning is MVI stands for move immediate. So move the immediate data 00 to C register. So what will happen to this instruction is whenever this instruction is executed, C register is clear. That is the content of C becomes 00. So here, if we write the opcode list, so here MVIC, that is move immediate C. So that is the instruction. And for this move immediate C, if you refer the 8085 opcode sheet, the opcode is 0E. So listen, this 0 CS, listen, this is opcode. For move immediate C, if you refer in the 8085 opcode sheet, you'll be getting 0E. So 0E is the opcode and the numerical data 00 is the operand or data. So this move immediate C, comma 00 occupies 2 memory locations. That's why it is called 2-byte instruction. Consider another example, that is ADI 45. So ADI means AD stands for add, I stands for immediate data. So add the immediate data 45 with the content of A register. So here one instruction, that is one data is understood. That is, for any arithmetic and logical operation, one data should be in the A register. So the content of A register and the 45 is added. So that is the meaning for ADI 45. So while we write the opcode, first if you refer the opcode for ADI, the opcode is C6. And here we have mentioned the numerical value 45, that is called the operand. That should be written in the next memory location. So C6 is the opcode and 45 is the operand or the data. So since ADI 45 occupies 2 memory locations, so already we have discussed that in one memory location, only 1 byte can be stored. So since this instruction needs 2 memory locations, this instruction is called a 2-byte instruction. Next, we'll be going to the 3-byte instruction. So in the 3-byte instruction, we'll be having the opcode plus data byte plus data byte. So in a 3-byte instruction, the first byte indicates the opcode and the following 2 bytes specifies the 16-bit address or the 16-bit data, whatever it may be. So consider the first example, LXI H, 8500. So already we know that what is X. So L stands for load. X is register pair. So it is not H register. It is HL register pair. In one register, we can store 8-bit. In the register pairs, that is in HL register pair, we'll be storing the 16-bit. In one register, if we know that a register can store only 8-bit. And similarly, a register pair can store 16 bits. So what is the meaning for LXI H, 8500 is load the immediate data 8500 in the HL register pair. So while we write the opcode for this instruction, if we refer the opcode sheet for LXI H, I'll be getting the opcode to be 21. So here, listen, this 21 is the opcode for the mnemonics LXI H. And you are having 16-bit data. But already we know that in one memory location, we can store only 8 bits. So this 8516-bit is split into 2 parts. One is 00 and 85. This 00 is lower order byte and 85 is higher order byte. While we write in this, that is opcode list, first we have to write the lower order byte first and then the higher order byte. So here for LXI H, the opcode is 21 and next comes the data, that is our lower order byte. So this is my lower order byte 00 and the higher order byte is 85. So this LXI H, 8500 instruction has one opcode plus 2 data part. Okay, so this instruction occupies 3 memory locations. That's why it is called 3-byte instruction. And next comes to the another instruction, STA 4500. The meaning for STA is store the accumulator. Okay, store the accumulator content in the memory location 4500. So here 4500 is the memory location and the data in the A register is stored in 4500. Okay, if you refer the opcode list of 8085, for STA, the opcode is given as 32. So the first part is opcode, and as we have already discussed in the first instruction, this 4500 is a 16-bit value. So it is split into two parts, that is 45 and 00. So first we need to write the lower order byte, that is 00 is written here. So this is our first data, and the second data is 45. So STA 4500 occupies 3 memory locations. That's why it is called a 3-byte instruction. Thank you for watching this video. Thank you so much.